So let's see how the points are distributed on this question, number one. And we don't know for certain how they're going to do the points this year because the test is different. We don't know what they're going to do. But the best we can do is assume it's going to be somewhat comparable to what they're doing here. So what we have is all 9-point questions. You know, they're going to do a 25-minute question. Is it going to be more than 9 points? I don't know. But again, our standard questions are 9 points. So in our first part, we got 1 point for the integral and 1 point for the answer. So if you look at what, we wrote here, that means, by the way, that just writing this was worth 1 point. Even if we got the wrong answer here, if we just wrote integral 0 to 5 of e of t dt, that's worth 1 point. And then our answer was worth 1 point. Notice it doesn't say anything about units because the question didn't say anything about units. So that first one was 2 points. Our second one is 2 points. So again, it's just the integral and the answer. So for our integral, if we just wrote this, that's our integral. Sometimes if it's a multi-point question for an average, they'll separate out 1 point for the constant in front and 1 point for the integral, but they didn't do that here. It's just 1 point for the integral straight. And then 1 point for the answer, so the answer, not the units. So if we got that 6.059, we got that right, and it's 6.059. All right, so then for part C we could easily have guessed was going to be the higher point value because there were more parts to it. It was more to do. So that's generally going to be the case. If there's more to do, it's going to be more points. So look how we get 1 point just for setting e of t minus L of t equals 0. So we did that here. So as long as we have that, that's worth a point right there. That was 1 point. And then getting the answer right is 1 point. So we said t equals 6.204. So that's 1 point right there. Notice that we could have said 6.204 or 6.203 because the rule is 3 decimals truncated or rounded. We chose to round, but you could also have truncated. Okay, and then for the justification, notice what they've put for a justification. So here's how we did the justification. We made this table of values and we said, therefore, the greatest number of fish is at time t equals 6.204. That's our justification. We created this table of values. All right, and then we said the maximum number of fish occurs. So just by showing f of 0, f of 8, and f of the critical point, that's our justification. But remember I mentioned there's an alternate justification, which is that if you notice that the derivative is positive for all t less than the critical point, and f prime of t is negative for all t greater than the critical point. So we know that the function has to be increasing over the whole interval and then decreasing over the whole interval. Therefore, the max you get had to be an absolute max. We know that the graph looks more like this and less like this because there weren't 2 critical points. So again, that justification, you can use it. That's an or. All right, that justification, you can use it. I don't like to use that one in general because it's specific to the idea that you only had 1 critical point. And you could have had a critical point that was like this, right? So then you would have f prime positive and then f prime positive again. So there are lots of different things that could have happened to alter this argument, whereas this type of argument is always going to be the same. So it's a nice thing to fall back on. It's reliable. All right, so that's our third point, is for all this justification that we have here. All right, and then for part D, all we have to do is consider e prime of 5 and L prime of 5. We don't have to know what they are. We don't have to get them. We don't have to subtract them. We could have added them instead or done something stupid with them, as long as we thought about e prime of 5 and L prime of 5. And we did that right there. So there's 1 point. And then answer with explanation. So here's our answer. The rate of change is increasing because f double prime of t is less than 0. It's possible that I would lose the answer point here because I didn't say the rate of change in the number of fish is decreasing at time t equals 5. And that's really critical for them because that rate is not always decreasing. So I need to say that is increasing at t equals 5. There's a good chance I would have lost that point on that one. But that's your third point, is the answer with the explanation, which is because f double prime is less than 0.